Okay, 6.3 properties of parallelograms. So, if I asked you what a parallelogram was, what would you describe it as?
Something that has parallels.
Well, yeah, obviously in the name, right? How much parallels? What? What?
Sets.
2 sets?
Sets.
Okay, so 2 sets of some parallel sides. What shape would you say is a parallelogram?
Square.
A square is a parallelogram? Do we have another one?
Rectangle.
Rectangle is over here. Okay, a rhombus is not a parallelogram. So you have the 2 shapes that you can identify are squares, rectangles. Okay, but on your paper you have that rectangle that what? It looks like I hit it a little bit.
Slants.
It slants. Okay, is this a parallelogram?
Indeed.
Yes, because they have 2 sets of parallel sides. Shaylee, give me 1 set of parallel sides. C what?
D.
Shaylee. Okay, so he helped you out with CD. What would be parallel to CD, Shaylee? Okay, and I'm going to put A, B for a reason here, you'll see. Okay, so that is 1 set of parallel sides. Okay, Mason, can you give me another set of parallel sides?
BACD.
B, no, it's the same. That's,
BC.
we got these already.
BC.
What's the other set?
BC.
BC and what?
EA.
Okay, BC, nope, I'll go with BC and DA, and I will tell you why in a second. Okay. And the next thing, it says blank is a transversal, so parallel line transversal properties apply. What is a transversal? What?
BD.
BD is a transversal. Now there's another one there, but it's not marked.
CA.
CA, how about we do AC? Just because. Okay. So all of my parallel line transversal properties apply. So I'm going to make my lines darker so we can see them. So if I do this, yes, and I extend this out, and extend this out, and this out. So doesn't it mean that this angle is congruent to this angle? Because they're alternate interior angles, aren't they? Okay, well then that would mean this angle is congruent to what?
That angle.
That angle. Well then, we said there was another transversal, didn't we? Here. So that would mean this angle is congruent to that angle. And this angle is congruent to
The other side.
that angle. Okay? So that means that if I'm talking about just in this shape, that AC is congruent, A is congruent to what? C? And B is congruent to what?
D.
D. That is why up here I made you said CD. Why did I make you put AB? Because C and A are what? Congruent. Everyone make sense with that one? Now the worst one over here was this one. You had BC and DA. Well, B and D are the congruent angles, so they had to go correspond, right? So last year when I did these notes, I had this whole list of congruent parts, and I think it got really, really confusing. But I need to remember I have a transversal, so all of those properties apply, right? Now I'm going to make this picture even more confusing. I know that this angle right here is congruent to this angle right here because they're vertical, yes? And I know this side is congruent to that side, and this one is congruent to this one. Well, by angle side, isn't this triangle congruent to this triangle? And this triangle is congruent to this triangle? Yes. Which means that this whole triangle over here is congruent to what? That whole triangle over there. So do we have a lot of stuff that can help us find parts of this parallelogram? Yes. And that is our learning goal today, is to find parts of parallelograms so we can use everything we've learned to do that, can't we? So next one, the hardest question of your whole day. I don't want anyone to blurt it out. It is missing a line above YZ. I do apologize. Put it there. What is YZ?
I don't know.
Don't blurt it out, Brian. Give him a second. Brian, what is YZ?
3.27.
How did you know that, sir?
Because it's X.
I know.
W is 3.27.
Okay, because XW is 3.27 and these are congruent, yes?
I think so.
Cooper, I will give you a chance. What is WZ, Cooper?
5.09.
How did you know that?
Because XY is congruent to WZ.
Because XY is congruent to WZ and it is 5.09.
It's like why do you think Y is like that?
What?
Is that a Y?
Yes.
Why not?
So, finding the sides are pretty easy, right? Now, what could you tell me about these angles? Anything?
They're angles.
They are angles. Good job.
Oh, no.
Good job, Mason. Anything?
All the same, yeah.
What?
All the same, yeah.
I can't.
They're all the same.
No, they are not all the same. There's no way they're the same. Because this one's closed and this one's, like, this is open and this is more closed. There's no way those are the same.
You were
It's not a
saying
square.
that. Henry's right.
It's not a square, is it? What do you know they all add up to be?
180. No, 360.
360. Because it is a quadrilateral and every quadrilateral has a sum of 360, right?
Mm-hmm.
So all of them add up to this, the interior, equal 360. Anything else? Not yet?
Don't get down to my problem.
Okay.
Fine.
So I'm gonna draw my picture again because we have a statement we need to fill in. So I said this was a transversal, yes? If I could draw a straight line. I'm doing a horrible job at it today. Okay. And this is parallel to this, yes? Well, what do I know about same side interior angles?
180.
They add up to 180, don't they? And I got some same side interior angles, don't I? Yep, I got this one and this one. So I got this one and this one. Well, if I know that angle X is congruent to angle Z, yes? And angle Y is congruent to W. And what did we just say about these two angles? And these two angles? And these two angles? And these two angles. What are they to each other?
Parallel.
They're not. Angles can't be parallel.
Congruent.
They're not congruent. You just said same side interior added up to what?
180.
180. So what's the word for 180?
Linear pair.
No. Linear pair are these.
Supplementary.
Supplementary. Good job. Consecutive angle theorem. I touched it with my hand. Jumped on me, guys. Sorry. Okay. Consecutive angles theorem. If a quadrilateral is a parallelogram, then the consecutive angles are...
Finger.
No. Supplementary. My pen is lagging and it's bothering me. They are supplementary. So that means that AB add up to 180. BC add up to what?
180.
180. CD adds up to. And AD adds up to 180. And then it just says it as if this would make it a parallelogram, yes? And these just say they're supplementary. They're if-then statement. So that makes sense because of all the parallel and transversal. Ryan, sit up, please. Okay, the next one, it says bisector theorem. If a quadrilateral is a parallelogram, then the diagonals, hint, it's in the name, bisect each other. What does it mean to bisect?
Square root of 2 equals 1.
intersect, dividing into two equal parts, correct? Could that be helpful? Yes. Now, it didn't say the diagonals equaled each other, but it says that AX and AZ are congruent, and it says that AY is congruent to AW. Again, it doesn't say, Shaylee, put your glasses on, you can see better. It doesn't say that the diagonals are equal to each other, but it does say that the two parts are equal, correct? Okay. The diagonals are equal in another object, not a parallelogram. So now we're going to just apply all those things we've learned. Y'all ready? Okay. So on these, please don't blurt them out. I want everyone to come up with a plan. And then I want a hand so people can still think. The quadrilateral PQRS is a parallelogram. What is the value of x and all the sides? So solving problems like this is nothing new for us, is it? You're right. It's there. It's right there. Okay? So we need to remember what do we know is congruent? Well, we're talking sides, right? Who wants to help me out with the strategy? Henry?
Add up all your like terms like the x's and
Oh, yeah.
3, 12, 3.
Okay, now, but do I have a relationship? Like, what is the relationship I know from my sides? Like, from your other page? What information did you get about sides?
You add like the top and the sides
Right, so the top and bottom are what?
parallel.
They are parallel, but the side lengths are what? Cooper, help them out.
The same. Congruent.
Congruent, right? So the top and bottom are congruent, and the two sides are what? Congruent. So what could be a strategy to find x? We can't add them all up because
Add the two congruent ones and then equal to the other two congruent.
nothing said they equaled.
Then add.
If I know that this is congruent to this, what do I need to do with the two statements? Shaylee? We can't add anything. We have nothing about adding. I want you to dig back. What did we do?
Equal those
Yes, why can I equal them?
because they're both the same size.
They're congruent, yes? So if they're congruent, they're equal. So I just set them what? Equal. Have we done this before? Yes, many times, right? Well, what if I didn't want to do the sides? Could I do
Top and bottom.
top and bottom? But can I intertwine the sides and the top and bottom? No, I have nothing that tells me a relationship between those things, right? So let's see. I like to keep my x's positive. Anybody else? I'm going to subtract 4x and add 3. So x is
1,
3.
3.
Wait, what?
Oh, like.
Okay.
Oh, yeah.
So if x is 3 on the sides, it better also be 3 on the top and bottom, right? So subtract 2x and add 3. So you get 5x equals 15. So x is what again? 3. So I found x. Now what else does it tell me to do? Plug it back in. So 4 times 3 is 12. And then 5 times 3 is 15 minus 3. And it better equal what? 12. Does it?
Yes.
Okay. And then 7 times 3 is 21 minus 3 is 18. And the bottom better equal what? 18. So 2 times 3 is plus 12 is 18. So did it work out for us? Okay, and again, you guys kept trying to add up all the sides. Do I have anything that tells me about the sum of the sides? No, we have the sum of the angles, yes, but anything about sides? No, we've talked about that before. A rectangle can be, a rectangle has 4 90-degree angles, yes? Okay, but just because the angles are equal, does that make the shapes Congruent?
No.
No, because the football field has 4 90-degree angles, and I don't think that table is congruent to the football field, is it?
It is.
Okay, so don't mix those concepts. Okay, again, I want people to develop plans on their own, so no blurting. Given the parallelogram A, B, C, D, what are angle A, B, and C? Because we know angle D is what? 114. So take a minute. See what you can do.
I got it.
You got it? It's pretty quick.
Pretty easy, like,
No, I don't actually have it.
You have a plan? Okay, that's what I want. Ryan, are you awake?
Yeah.
Spacing.
easy to.
Brian, you got yourself filled in? Okay.
That's what I'm gonna say.
You guys ready for Brian to give us a plan? Mason, are you ready for Brian's plan?
I don't want this plan.
You don't want his plan? I think I do. I think I do. Okay, Brian, what did you do?
Alright, so you take 180 minus 114.
Okay,
Minus 66.
so 180 minus 114. Who all did that?
Me.
Okay, we got 1, 2 people? 3, 4. Okay,
Yeah.
so you got 66. And where does 66 go then, Brian?
Angle A and angle C.
Angle A and angle C. So angle A
Is angle B.
is congruent to angle C, which is 66.
And
Just a second. You're on a roll. I'm gonna come back to you, because Brian knew that these two angles here and here are what to each other? They're supplementary.
Oh, those two.
Okay, so they're supplementary, so they have to be congruent to each other as well. Now, Brian, how did you get angle B then?
So, angle B and angle D.
So angle B and angle D are congruent,
Yes, and they're 114.
so they're 114. Mason, his plan was good.
No, it wasn't.
Okay.
I wouldn't trust
Thank you, Brian. I believed in you, Brian. So, can those supplementary angles make this job pretty easy?
it. Sure.
Okay. Now, I want to know if anybody did this differently and got the same answers. How'd you do it, Mason?
Alright, so I put 114, like, angle B.
Okay, so I'm going to erase can I erase my drawing,
Minus
guys?
1,000.
Okay, Lyndon, can you please let him talk?
I was right.
Okay, so you put 114 on B.
Yeah.
Okay, then what?
When I added 114 to 114,
And so you got 228.
yeah, then I took 360 minus 228,
Where'd you get 360 from, Mason?
the total.
The total, Mason knew that all the angles added up together are 360. So he subtracted that and got 530, 132.
Yeah.
And then you did what?
130 divided by 2 for the two missing.
132 divided, so 2 goes into 13, 6. Carry 1 is 6.
Yeah.
So because he knew that these two angles are congruent. Okay, is there anything wrong with the way he did that? No. Good job, Mason.
Your plan sucks.
You stopped? Did you?
So is yours.
Okay,
Mine's better.
guys, I don't appreciate it. Stop. I know you're joking, but still stop. It's not helpful. Henry, remember that these two are congruent, so if you got 132, you just had to share that 132 equally between the two. So you were on the right track. Just remember that those two angles are congruent. Okay? Raya, did you have a question?
No, I was fixing my glasses.
Oh, okay. Any other statement on that? I don't think there's another way to do that.
You could turn it into a triangle.
Well, yeah, you could turn it into a triangle, but then you've cut these two angles. And then it was... Well, I guess you could do an isosceles. So you could take 180 minus 114, right? At 14. And get 6, 7, 66. And then you would probably divide it by 2, but then multiply by 2. So yes, you could. So is there only one way to do these problems? Not usually. Okay, next one. Given the parallelogram, what is the value of A? And then we are going to find angle G, H, J, and K. So I'll give you a minute. Think about it. These problems start seeming very similar to ones we've done in the past chapters once you stop and think about them.
Yep.
It pretty much comes down to, are they congruent or are they supplementary, right? So, Cooper, Linden, you got answers?
I'm trying to think how to start it
Okay.
because they're not equal.
No, they are not. You're correct. But what do you know about those two consecutive angles? Henry?
Angle G is A plus, or 8A minus 5, then WJ has to be the same.
H and K are the same.
Okay, H and K are the same, but what do we know about the relationship of G and H? They're what?
Supplementary.
G and
They're
H.
supplementary. So if I add them, they equal what?
180.
180. So is that what I should do?
So
180.
Levi.
So 180 equals what?
Oh,
A plus 5.
A plus 5, then what?
Plus
Plus.
80.
8A minus 5.
Yep.
And then you add them.
And you add them, so you what? Get 9A?
Yes.
And the 5's zero out.
Yep.
So what is A?
90.
No,
20.
No.
20.
Oh, yeah.
Because 180 divided by 9, 9 goes in 18.
Too good, dude.
Okay, so if A is 20, now you guys already said it, that angle H was congruent to what?
Okay.
K.
H and K are 25.
And so that would be A, which is 20 plus 5 is 25. And angle G is congruent to what angle? J. And that's going to be 8 times 20 minus 5. So 8 times 20 is, what's 8 times 2?
160.
60. So it's 160 minus 5 is 155. Now, what do these two have to total? What's 25 and 155 have to add up to be? 180, do they?
Okay.
Do they add up to 180?
Mm-hmm.
Yep. So I'm checking my work, aren't I? Now, some people would say, ooh, I got 25. I can just take 180 minus 25 and get the answer, couldn't I?
Yeah.
But what if I accidentally did 20 plus 5 and wrote 15? Okay. Well, I would get H and K wrong, but I would also get what? G and J wrong? So if you plug them in independently, could we go back and check that the two added up to 180? Yep. So be careful of using one thing you found to get the next thing if you don't have to, because it might mess you up. So, how did we set up our problem on this one? What did we know about H and G? They're what? They're supplementary, and so that means they're 180, so I just added them, right? Okay, 2 more examples, I think. Given the parallelogram RSTU, SU is 35 and KT is 19. So what is SK? Now, what did I mess up on these? Forgot my lines, didn't I? And RT, what are they? Okay. So you guys want to start with SK or RT first? SK? Okay, so I have SK, but I do know that SU is 35. So SU is what? The whole thing?
Yep.
So how much of that is SK?
17.5.
Half of it. So I have 35 divided by 2.
It's 17.5, right?
Well, let's make sure. So 2 goes into 3 how many times? 1. Carry a 1.
7.
2 goes into 15. 7. Then add my decimal. And 2 goes into 10. 5. Now, guys, I'm going to stop you on this. I graded a lot of homework and didn't get full credit because people didn't show work. Okay? 35 over 2 is your work. Please show it to me, okay? I need to know what your brain is doing. So then we have RT. So I know KT is half of that, right? No, I just gave away. I know that KT is 19. How am I going to find the whole thing? 19 plus 19 or 19 times 2. And either way we get 38. Now again, we have nothing that tells us about the measure of those, right? We can't like say, oh, they equal 20 like we did 360 with the angles. Sides are completely independent of that rule. So you have to make sure you're using the correct things. I want everyone to look at this problem and how we did it and make sure that you could replicate that. Do you understand that SK is half of SU? And do you understand that RT is twice the length of 19? Because the next one's going to get a little bit, not much, more involved.
2/3.
Am I good?
I don't like fractions.
Okay. Oh, just keep your brain in the building. Okay. Given the parallelogram GHJK, PK is 4, and HK is 2/3 GJ, and I want GP when I'm done. Okay. So let's see what we have. We know that PK is 4, yes?
Yes.
Well, we need HK. So if PK is 4, what do we know about HK?
8.
It's 8 because HK is 2 times PK, which would be 8. Well, couldn't I replace this now in here? So 8 equals 2/3 GJ. I got half my lines there and not the other half. Okay, so I need to move a fraction from one side of the equation to the other side. So I have to multiply by its what?
Reciprocal.
Reciprocal. So that'd be 3/2. And if I do it on the right, I have to do it on the what? Left. So here they reduce to 1. So I'm left with GJ. Well, this is 8/1, isn't it? Does 2 go into 8?
Yeah.
4. And 3 times 4 is
Well,
12. So I know that GJ is what? 12. So how can that help me find GP?
12 divided by 2.
GP is going to be GJ. You're right, Cooper. Divided by 2. So 12 divided by 2 is 6. Now, there was a fraction. Was the fraction difficult to deal with? No. We need to start learning to keep our brains in the building when it comes to fractions because they're not going to go away. By the end of the year, if you avoid all problems that are fraction, you're going to be avoiding about 50% of our problems. That's not going to do well, is it? Lyndon, can you place it up? Thank you, sir. Questions on this problem? Okay, so we have a good chunk to start working. So we got 14 minutes.